Hi, everybody. I am Jen Brock. I am head of product here at Carroll.
And I'm Ben Shepard. I am our TCI curriculum coordinator, and I work a lot with Jen in our data and research department.
Yep. And so, what we're going to be talking about tonight is how our targeted cognitive intervention program accelerates learning for Carroll students. And as we get into this, I wonder, Amy, can you go ahead and launch that poll for me real quick? I just want to get a sense of where we have attendees, if we've got lower school, middle school, or upper school families. If you are a potential Carroll family or joining us next year, let us know where your kid will be next year. Right. Looks like we got a pretty good spread of attendees. All right, awesome. So it looks like we've got what, about 17% of you from the lower, and then the majority middle and upper. Um, so that is helpful for us. Thank you all. All right. So we're going to cover, you can, I think, make the poll close. I'm going to close it out of my screen anyway. I just want to bring up our agenda. We're going to go through a few things tonight. We're going to start with the most amazing overview of the neuroscience of reading. We are going to put an entire graduate school course into about 20 minutes with you. And then we're going to go into the details of the targeted cognitive intervention curriculum. And from there, we're going to focus in on the data that we have showing the efficacy of what we're doing. If you have any questions at any point, please go ahead and put them in the Q&A tool. There should be a button at the bottom of your screen. And if we don't get to your question tonight, we will follow up with you. All right, so Ben, over to you. Let's get going.
Absolutely. I am excited to talk to you guys about the neuroscience of reading. And we'll be testing you later on all of this information. So I hope you're taking notes. Um, Kidding. We're not doing that. We're going to throw a lot of information at you right now. And I hope that it is digestible and in a way that you guys can relate it to your students and help understand their learning profiles a bit more. So the first thing we're actually going to look at is, and I don't like to bury the lead if you've seen me on these before, but we're going to look at the brain of an individual reading the word cat. Simply reading the word cat. No other words, no context, just the word cat. And what is really interesting about looking at reading and language this way and how the brain activates with that is is that it is such a simplistic view of how we read. There are so many aspects of comprehension and integration of information that take place when you're doing connected text and shifting from word to word. But we're trying to isolate it into its most simplest form using cats. So the thing I want to point out here before we move on a bit is just how quickly this is happening. So what you're looking at on the right is a brain scan, an fMRI of this individual's brain reading the word cat. And it is lasting for about half or 500 milliseconds or so, this entire sequence of activation. So this is really fast. This is happening at high speeds throughout our brains. And Jen, if you want to go on to the next slide, let's talk a little bit about the brain before we come back to that image that we just saw. The brain and the cerebral cortex, the bumpy part on the outside of our brain, is broken up into different areas that are responsible for different types of information processing. Starting at the back of the brain on the right of the screen, we have the occipital lobe. Now, the occipital lobe is where we process visual information, the information that comes from our eyes. The temporal lobe, kind of moving up, is where we process our auditory inputs from our ears. This includes language processing, conversations, but it's also where we process things like music and other auditory stimuli that we hear. Above that, in the yellow, is the parietal lobe. And the parietal lobe is responsible for our sense of touch and our proprioception, our ability to navigate space. And that includes both understanding time, order, and how things relate to each other physically in three dimensions. Moving even further forward to the frontal lobe, this is the part of our brain where we really do our high level thinking. It's where we problem solve. It's where we process and regulate our emotions. It's where we engage our working memory. And all of these areas are so important for almost everything that we do in our lives. But that holds very true, especially for reading. Now, we're going to take a look at the traditional way that we break up the reading into its kind of component skills on the next slide. So if you've been to some of these talks before, you've seen the reading rope. And the reading rope is a tool and sort of a metaphor that us as reading educators use to show how there's many component skills that add up to a skilled reader. And what I mean by a skilled reader is reading fluently with comprehension. Reading without comprehension and understanding is sort of missing the point. So, our goal with every student here at Carroll is to build an efficient reading network that engages reading both fluently and with comprehension. To do that, we have to look at the component skills that go into reading as a whole. And so, when we look at reading the word cat and how it relates to the brain on the next slide, we can see that there's a lot of different things going on here. So let's just say I know the word cat. Phew, thank God I know the word cat. It's a sight word for me. It's something that I recognize. I'm taking that in visually, I'm turning it into language and into meaning. All really quickly within that 500 milliseconds. If I don't know the word, I have to sound it out and take a little bit of a different pathway through my brain using the tools and approaches and strategies that the Orton Gillingham curriculum is so excellent at giving students and budding readers for decoding words that they don't know that follow the predictable patterns of the English language. And this all engages our phonological awareness, which is really moving the information from the visual, that occipital lobe, into the temporal lobe. But without connected text, and I'm taking it out of the context of cat here for a second, you start to have to integrate it into your language system. When you're reading, you're engaging in language and understanding. And the way that we do that is through the temporal lobe, but also that frontal lobe, where we start to understand relationships between the words, how they relate to each other, and start to combine to form a narrative. Now, if we put that all together and we look at what's happening in the brain as we're reading the word cat, you can see that the information that's coming into the brain is flowing in through that occipital lobe in the back, up through the temporal lobe, into your frontal lobe, and then kind of out back into your motor cortex for the speech output of it. One of the most fascinating things to me that I've learned about language processing is that when we're processing language, but we're not orally or audibly saying it out loud, we're actually activating the same neural networks, the same pathways in our brain that we would, minus the motor cortex and the output. So when we're reading, even if we're reading silently, these language systems are all in play, and they're all activated and working together to form the narrative. Now, we actually have a more detailed view of the brain. And this comes from a French researcher named Stanislas Dehaene. I butchered that name. Stanislas Dehaene. He wrote this book called Reading in the Brain, highly recommended if you haven't read it already, but lays out a more complex and nuanced network for reading. You'll see that it includes the visual inputs where we process the original visual information from our eyes. It goes into our visual word form area in the red, or our brain's letterbox, as Dehaene calls it, which then gets transferred into meaning, which then combines into understanding, pronunciation, articulation, and the overall thing that's driving this is kind of our focus and our attention to the task at hand. So the reading network that's been established over the years has really grown with our understanding of the brain. There's a multi-sensory areas of the brain that are really important for processing visual information, auditory and language information, for the motor outputs of speech, and also understanding the spatial relationships of the letters as they are laid out in a word. Understanding that the C comes before the A, comes before the T is an important detail when we're reading. And this word, reading the word cat, goes through all of these different areas, depending on the patterns that we know of the English language. We use that to help us decode unfamiliar words. Familiar words actually bypass that circuit entirely, and we'll get into that in a minute. But let's go back to looking at the brain and how it's processing the word cat with this more nuanced perspective of the reading network. So again, what we're seeing is the inputs coming in through the visual system, going through that letter box where that kind of red dot is on the left, into our access to meaning, into our prefrontal cortex where we're checking for understanding, we're checking if for any errors that are happening, and then through our articulation loop kind of back towards the back of our brain. As we're reading these simple words, we're doing this quickly. We're doing this and trying to build accuracy as students are developing readers. Now, how are typically developing readers different than students that have dyslexia? What we've learned with some of our collaborators, this one in particular, Rebecca Marks from Purdue, is someone who helped us put together a lot of this data and some of our presentations. And one of the things that she's found is that there are some underactivated areas of the brain in students with dyslexia. This is a corroboration of a lot of other research that also supports this notion that there are parts of our brain that are underdeveloped as dyslexics. Particularly, we're looking at the left side of our brain, where a lot of these skills get left lateralized as we become more fluent and as we become skilled readers. So you'll see on the right where the light blue and the light green ovals are, those are areas that are underactivated in students with dyslexia. Now, recently, maybe not super recently, but over the last 10 years, we've developed a new form of imaging, of using fMRI imaging called diffuser tensor imaging. And this actually allows us to understand the structures and the pathways within our brain. And this really is a really cool tool that helps us understand the physical anatomy of our brain a lot better and what's connected to what. The next slide shows us a kind of an overview of the types of things that we can start to see with this type of technology. We can start to understand how information flows from the back to the front of our brain, from the right to the left of our brain, and how we kind of connect information into a narrative or into an episodic sort of memory of a moment or an experience. Now, to go back to that first DTI image that we saw, I want to just orient ourselves again to these parts of the brain. The occipital in the back is where our visual inputs come in. The temporal region comes out on a little bit to the front of that, with the parietal above it and the frontal cortex even more in the front of our brain. So some important pathways for us to think about are the ones that connect our visual system to our understanding and our meaning. One particular pathway that's come out in the research, this arcuate fasciculus decoding pathway, is where we really start to engage our brain and our neural pathways when we are decoding unfamiliar words. This is where we have to engage with the Orton-Gillingham principles and the structured phonics patterns of language. You have to see the thing. You have to understand what the pattern you're recognizing is. Is it a open syllable, a closed syllable, a VCE syllable, in order to get that meaning and the sounds that are associated with it accurate. Now, as we become more fluent, the information is actually processed in a slightly different way. It still comes in through our eyes and through the occipital lobe, but it gets sent on this fronto-occipital fasciculus pathway. These are the vocab words for later. But this is where we read fluently, and it bypasses a lot of the other information processing that goes on when we're decoding. If we're familiar with a word, like the word cat, we can see it and recognize it a lot quicker than slowing ourselves down and decoding. One of our collaborators, Professor Gabrielli at the McGovern Institute at MIT, has shown time and time again that when you actually take students that have dyslexia, that have some of these areas of underactivation and these areas that don't connect as well from the occipital to the temporal to the frontal parts of your brain, that if you give them a structured reading approach, such as Orton Gillingham, then we can actually change the activation patterns within our brains to become more similar to typically developing students who didn't have the same struggles as those with dyslexia. So this was one of our key kind of seminal findings in research articles that really helped us build a program that both supports reading through Orton Gillingham, but also supports the underlying cognitive pathways and capacities that are crucial for achieving skilled reading. Along the way, we've had some friends that have helped us with this also. This Meisler and Gabrielli article in 22 really helped us understand the impact of some of these structures of our brain, of that arcuous vesiculus, and helped us understand that in students with dyslexia, that neural pathway is actually thinner and less developed than a typical reader. And a way that we've learned over the years of how we can remediate that is by sending information through it and growing it because it's a muscle, just like any other of our muscles. Moving down this list, this other 22 article from I can't say Faccoetti, the second guy for out of Italy there, did a lot of work on the impact of visual attention and how the efficiency of our visual system supports reading, and how there's a subcomponent of students with dyslexia that do struggle with things like their saccadic eye movements, how you move your eyes from one letter to the next while you're reading along a page. Also, that their visual attention system as a whole, whether it is more distractible or gets overwhelmed easily, are areas that can actually be trained and through things like video games. And most recently, well, maybe not most recently, I guess also in 22, Al Dehane came out with an article along with a lot of along with Gabrielli, Professor Krista Dulo at the Institute of Health Professionals, along with a former colleague of ours, Dr. Falk, and Carroll helped out with some subjects for this one too, where we looked at students that have executive function struggles and how they perform on reading tasks. And what they found is that there are some specific cognitive measures, being that of processing speed and of working memory, that seem to have a large impact on your ability to become a skilled reader. If you have reduced capacities in those areas, it's much harder for you to naturally achieve that point, particularly compared to typically developing students. So Carroll's answer to this is to add in to that reading rope that we looked at, that Scarborough reading rope, a cognitive perspective. And the way that we do this is we measure this over time, multiple times a year, but we're measuring areas of cognitive efficiency, of reaction time, of your processing speed, of your ability to shift your attention and focus from one thing to another, and of your visual working memory. Now, these are four cognitive areas that are crucial for learning and for skilled reading development, but there are definitely other areas that impact it as well. Verbal memory for one, and language comprehension and language understanding as a whole. The other one that I'll mention is your ability to regulate your emotions. One thing that we know about our brain is that there's an overlap between working memory and emotional regulation, and those actually take place in the same part of your brain. So if you're stressed out and feeling a certain way after, say, recess or a bad day, you have less capacity to engage in complex tasks because your working memory is reduced. So if we can support these areas and give our kids more capacity in their working memory, in their efficiency for sending information between those parts of a brain, could we see better learning outcomes in reading? And I'm going to pass it over to Jen to talk a little bit more about that.
Thanks so much, Ben. Every time Ben gives this talk, I feel like I learn something else about the brain. Really awesome, awesome information. So what I'm going to focus on next here is really what is TCI. Um, and what we're doing in TCI, Ben has talked about this, but I want to be really explicit about it. During TCI, we are doing cognitive training on these different underlying cognitive skills that are crucial for reading. During TCI, we are not doing any literacy work. We are not doing Orton Gillingham, practicing our word parts and our sounds and our letters and things like that. What's happening here is really focused purely on the cognitive skills that underlie this so that we can boost the capacity of those underlying cognitive skills that then allow all of the other amazing things that happen educationally here at Carroll to have an even larger impact. So what I'm going to do is I'm going to take you through the curriculum and sort of how this works. We are very much relying on that concept of neuroplasticity. I think when I first started in this work, gosh, a decade ago now, the idea that the brain can change and that the brain was plastic was pretty controversial. I feel like we've moved past that at this point, and you know, the research that we rely on here, where a lot of this came from, is rehabilitation associated with strokes and traumatic brain injuries and the like. And we're relying on those same things here. The brain is plastic; it can change, and that's what we're working on. So TCI starts by building a profile of what a student's current cognitive skills look like. And we do this with a set of assessments that are measuring those underlying cognitive skills around reaction time and processing speed, shifting attention, and working memory. And that allows us to do things like this is an example of one of our radar charts where we can really see the strengths and weaknesses for each individual student. What we're really focusing on here is how their individual brain is processing information. Um, this data is all automated. We partner with a company called CNS Vital Signs, who are very, very big in the computerized cognitive testing space. And so this data all comes through automatically and generates these cognitive profiles for us every time a student does this testing. Once we have that, we're able to assign individualized cognitive curriculums to each student based on the projected improvements in areas of greatest need. And I'm going to geek out just a little bit and tell you a little bit about how we do this. So, thanks to the incredible support we've had over the years here at Carroll, we've actually developed an entire technology platform that runs this whole program, that administers this program. And so we have machine learning algorithms, which I know everybody's talking about AI now and how cool that is. 10 years ago, we started using that here to predict how children's reading will improve based on different cognitive interventions. And so every student that goes through TCI is getting one of these individualized programs that is made up of computer games that target the underlying areas of weakness that they need to see the most improvement in. This algorithm actually has the ability to both look at it from an academic outcome perspective and also look at it as a teacher and say, what is it that this student really needs right now and to be successful? It's pretty amazing. I haven't seen a lot of other schools that do things like this. It makes me feel pretty honored to be at a place like Carroll that does work like this. So then what happens once students have their programs, the platform itself is actually bringing students through their individual games. Kids are playing between 6 and 8 games during TCI, during every TCI session. And so that works out to between 24 to 28 minutes of time on task during each class. And TCI is built into the schedule for students throughout the year. So all of our students in fourth through ninth grade are doing this, and our third graders are actually doing a slightly different program that I'll talk about at the end if we have some time. But the platform is bringing them through this and taking them through these games. one of my favorite things to do is actually pop into classrooms and see kids doing TCI. And this is what it looks like. The difference between these games and the games that your kids might have on their phones or on their Chromebooks that they want to play or their gaming consoles is that these games are specifically designed to target very specific skills. And so if we have a student where we're really trying to work on that reaction time, we can see one of our kids here is actually playing a game called Match It, where they're having to very quickly and accurately identify which one of the little animals on the screen matches her target. And so the kids are playing these, and it's a lot of fun, and it's also really hard. These games are designed to target the things that they have the most difficulty with. And so our teachers are trained to support that. Our counseling team is trained to support that. Our teachers are trained to support that. We mix in fun with it so that our students are able to really put this work in. It's really akin to doing physical therapy that you would do on an injury, or if you've had surgery on anything, it's just here. We're really doing that in the brain. Once kids play through their games, what the platform allows us to do is actually monitor what's happening within each of those games. Teachers are able to see this data. They're able to see how many minutes kids are spending in the different games. They're able to see the levels that are changing on a session by session basis. They're able to identify if a student is maybe off track in terms of their time on task minutes, if they're on track in terms of the progress they're making in each of these sessions. We have a lot of fun with doing different challenge days, fun days to really engage kids as they're doing these things. And I think one of the most valuable pieces that's happening during TCI is kids getting the opportunity to practice different cognitive strategies in a very low stakes way. It's a game. Worst case, you quit and you start over. There's no academic overhead here. And so it really gives kids an opportunity to do things like feel what it feels like to go a little faster, feel what it feels like to slow down a little bit. And I know Ben has the opportunity to see kids in class. I wonder, do you have a couple of stories you might want to share on this one, Ben?
Well, I think one of the things that I that really sticks out to me in terms of how we do this and how we differentiate and how we target students' area of greatest need, which means we're giving them the games that are hardest for them. And that really sucks. It's really hard
Mm-hmm.
to do the hard thing all the time. It's a place where they're practicing their resiliency and doing the hard thing throughout their day. And there's a lot of places where we want to give kids access, make them feel successful, and we absolutely do here too. But this is a great vehicle for us to be able to practice some of that frustration tolerance and that sort of grit and determination, resiliency to get out of that learning pit. That can be such an important tool for kids to learn for their academics and later on in life.
Absolutely. I think the other thing I've learned is how motivated our students can be by stickers and the sticker charts and the sticker wars that happen in each classroom, the competitions that exist between them to get the highest number of minutes, the most progress on levels to get to that next hard part to break through it.
It's amazing. Everyone wants a gold star, no matter how
Yep,
old you are, I find.
I do.
I want them. I do. I do.
Yeah, absolutely. Absolutely. Um, so as we go through the program, so TCI is like any other curriculum in that we're going to do some pre-testing to see where you're at. We're going to give you some interventions and some things that you're going to be doing during that program. And then we're going to test you again afterwards and see how you did. The activities that we use during TCI, the computer games, we partner with an organization called CogniFit. They have when we started working with them, we had about 30 games. We now have over 70 games that we're using with different kids for the different programs that we have. And what's nice is that the games are very different from the assessments that we do. So we're able to, from a research perspective, make sure we're not training to the test, which is a really important way to validate what we're doing because everything we do here is really driven by the data and in making sure that what we're doing is efficacious and valuable. And so we can actually see what happens from a pre-test to a post-test, and we can see those skills change. The platform actually generates these amazing reports for us where we can actually see the different kinds of progress that kids are making on subtests, on individual skills, and on their reading and their other academics, and being able to see where TCI kind of played into that. This data it fundamentally underlies how we give each child what they most need at Carroll. What we're doing in TCI is mapping how each of our students' brains are processing visual stimuli, how they're processing information. This is the data that our teachers are able to use to individualize the instruction in the entire rest of their day. So I don't think I can understate how useful the reports that we get out of this are. They're cool to look at, but they're also really essential for our teachers in terms of our day-to-day instruction. So that is the world's quickest overview around TCI. I am sure that folks are going to have more questions about TCI and the individual games and all kinds of stuff. We're going to put up a couple of email addresses at the end that you can send questions to. There's a great website on the Carroll website that has some information about TCI and a great little video overview. Maybe Amy, you can throw that into the chat for folks for that URL. And we also have a bibliography on another site we'll talk about towards the end, where you can read some of the research that Ben was talking about. So that gives you a nice overview of TCI. And it's great, and we love it, and we love doing this, and our kids, of course, love it and don't love it all at the same time. But so what, right? I can't imagine any of you get really excited about talking to your kids at the end of the day about the levels that they moved in Mahjong, or how they came up with this great new strategy. They finally figured out how to get past a level in Slice and Drop. While I'm sure this is really interesting conversation, the big question is the so what? How does what we're doing actually accelerate learning? How do we know that the activities that we're doing, how do we know that the skills that we're training on are making a difference academically for our students? So I'm going to ask you to bear with me for just a minute because I want to talk about averages. Because we're going to be talking quite a bit about averages and data. We at Carroll don't generally look at averages. We're looking at each individual student and what their individual learning trajectories are and what their very specific needs are. We need to give each child what they need to best thrive here at Carroll, academically, socially, emotionally. When we talk about data, we have to talk about averages. So we're going to talk about 10 years of data here, 10 years worth of students and averages associated with that data. It's different. It's a holistic approach. And I just want to make sure I'm sort of highlighting that this is a different way than I think you're used to in conversations when you're talking about your child. It's really all about your child. I'm going to talk about 10 years worth of kids here. The first thing I want to highlight, and for any of you data geeks in the crowd, I'm sure you're going to give me a little shout out here. The challenges with averages is that sometimes you lose things in the noise. There's a huge spread. This is just looking at WISC scores for our students. There's a huge spread in numbers. We don't want to, when we're looking at individual students, lose sight of where they might be on a particular scale. What we look at when we're looking at averages are really what those through lines look like, what those central points in the data tend to look like. This is showing us just WISC scores from the last 3 years. WISC is an assessment that probably all of your kids have gone through as part of their neuropsychological evaluations. You can see the average scores where they're being highlighted in here, but you can really see the spread of it. And so what we're going to be focusing on, again, as we talk about the impact that TCI has and how it affects learning, we're going to be talking about averages. We're also going to talk about percentile and percentages. So percentiles are not percentages. Percentiles are normed data, right? A percentage has to do with what percentage of things you may have gotten right versus wrong. What a percentile is really telling you is where a score lies in relation to other people like you, in air quotes. So other people your age, other people your exact age, other people um, who have the same sort of attributes that you have. Percentages tell us what you get right versus what you get wrong, but percentiles tell us where you are versus everybody else. And for those of you, all of you, our parents on here, you've seen this in your growth charts with your kiddos, right? That we expect, if you're in the 30th percentile, we're expecting a certain amount of growth over the course of a child's, development. And we expect if you're in the 30th percentile, you're more or less going to remain from a growth perspective in that 30th percentile. But if you jump up and you do more than that, right, which is what we often see happen here at TCI, you can actually make more progress. So a percentile assumes that it has that assumed growth kind of built into it. Zeros, when we're talking about percentiles, are actually really good. It means you're keeping pace with exactly where we expect you to be. Going higher, going beyond what a percentile is an indication of growth beyond what is normally expected developmentally. And so I put up the Hasbrook and Tyndall oral reading fluency norms here for you just to see this. These are measures of oral reading fluency, and what you can see is that the number of words correct per minute you're expected to have changes as you get older, even if you stay within the same percentile band, right? So even if you're at, say, the 50th percentile, you're expected to move from, say, 30 or so words correct per minute in first grade, closer to 140-ish when you get to eighth grade. So I hope that kind of helps set a little bit of a baseline for the rest of the data that we're going to be looking at. So the first thing that we find with our data is that um, we see improvements in kids' cognitive profiles. We see changes in them. We see, in fact, that we see improvements anywhere from 60% in visual working memory to 70% in shifting attention. What that means is students progressing more and becoming better at these skills than they are sort of expected to be normatively. You can think about this as closing a developmental gap, if you want to think about it that way. We've been tracking this data for 10 years. And so what we see is that since introducing TCI, we see 64% of our students improving in that reaction time skill, that really quick being able to visually correctly identify a visual stimuli. 66% of them improve in processing speed, in speeding up that circuit of processing information in the brain, that sort of wait, what? Speeding that up. 70% of them are improving in shifting attention skills, that ability to move quickly between different tasks. And 60% of them making progress in visual working memory, which again is being able to hold on to that visual stimuli as you're shown, or you look at that next visual stimuli, say a C, and then an A, and then a T.
If I
So
can
that's
level set
great.
here for a second, Jen,
Yeah.
this is amazing. Like to me, this is so amazing because when I was, so I'm a Carroll alum myself, and I remember sitting up in the Sturo building getting told that my processing speed is my processing speed and it will never change. And this is in 2000, 2002-ish.
Yeah.
Since then, we've learned so much about the brain and how we can improve these skills. This is still actually a pretty controversial fact that you can move the needle on some of these cognitive domains. But we're showing this time after time. And one of the things I actually love about this intervention, relative to how we've sort of learned about the education system as a whole, where often in typically developing and general ed populations, the structure is built so that the rich get richer. The people that are succeeding are the ones that are able to access the next things and do the best and keep getting ahead, while the kids that are on the other end, the lower end, tend to get lost and left behind. What we see is such a stronger response in students that are on the
Yeah.
weaker end of these measures of that bell curve, that are in the lower percentiles of the first to the 10th percentiles, because they have a lot of room to grow and they can respond so well to these types of
Yeah.
interventions. So it's just such a uplifting thing that we've been able to show over the last 10 years.
Yeah. And in fact, I was recently at the Learning Disabilities Association of America's annual conference in St. Louis. And I was sharing this data there and talking about it. And it was so great. You know, I think we take for granted at Carroll that that growth mindset and the work that we do can change these things, that they're not static. And I'm really glad you bring it up because I think so many people still think that it's static and it's not. And it was incredibly exciting to be able to share that with other learning communities. And, you know, part of our goal here is to spread that word that this isn't static. These things, these skills can change, and it is pretty amazing when they do. But again, so what? Are you talking at Thanksgiving about, oh my gosh, Timmy's reaction time numbers? They have gone up so much, right? Like, we really geek out on that. But what does that mean for reading? Like, so what? What's actually happening? So, what I want to do now is walk you through the improvements that we actually see in oral reading fluency with doing TCI. And all of this is coming out of the research papers and work that we've done. And I'm going to talk a little more about that in a couple of slides. This data is, again, 10 years of data, and we are comparing students who did TCI, who had TCI to students who were at Carroll before TCI existed. And we're able to kind of see the differences there. This is using the Read Naturally Benchmark Assessor, which measures oral reading fluency. It is 3 1-minute passages that kids read. They do that 3 times a year, and it measures the number of words they read correctly in a minute. We do that in the fall, the winter, the spring. You're used to seeing that data and talking about this in your data meetings and conversations with your child's advisors. We love this because it allows us to really isolate what's happening from a fluency perspective. And so I'm going to start going through here. And what we have seen is since we started doing TCI, 61% of Carroll students make expected or faster than expected progress in oral reading fluency, meaning that they're not just keeping pace with what we would expect at the sort of the level, the percentile they're at. They're learning more words. They're able to read more words to be able to do that faster, more accurately, and able to make progress against the norms. 61% of students. We've seen that here. And that is remarkable. Um, why does fluency matter? Fluency supports comprehension. If you cannot fluently read words, printed words on a screen, on a piece of paper in an efficient way, you can't read fast enough to comprehend the information that is there. And we know that as our kids get older, reading to learn is absolutely essential. Um, so 61%, that's amazing. That's great. What do Ben and I and every teacher here at Carroll wonder is, well, that's great, but what about the kids who are really struggling? What's that other 39%? What's going on there? Um, so all of our students have dyslexia. Some of them are skilled and fluent readers. They may not have always been, but they are now. And so their change here, you're not going to see as much because they're already stronger. They might still be struggling. They might still be learning, and we might not be seeing that progress here yet. There also can be students who are struggling with decoding. And so we're not ready to make those fluency improvements yet. We're still struggling on those decoding pieces. So when we build and we really tease apart what's happening with that 39% that aren't making the progress, we're still working on things for them to make that progress, or they're already strong enough that it's very difficult to see further progress beyond where they are. So that's nice, right? It's great. What about students who start weaker, right? You know, Ben talked about this. You know, when you're already stronger at a skill, you have less space to be able to grow and improve. What happens to the kids who are weaker at it? 70%. This is now looking at students who are starting with a normative weakness in oral reading fluency. And so this is looking at students who are below the 25th percentile in oral reading fluency. When we look at that group of students, that improvement percentage grows to 70% of students are making more progress in oral reading fluency than the norms predict. And when we look at the most significant weaknesses in reading fluency, 76% of those students are making greater progress than the norms predict. This is normative growth. This is closing that gap with typically developing readers to be able to read faster. We also don't look at just oral reading fluency. One of the measures that we've looked at quite a bit is sight word efficiency. And sight word efficiency is that being able to recognize those three letters of cat, and we know that that's cat, and we can recognize that very quickly. And we're able to look and compare with the students who did these sight word efficiency assessments before we started doing TCI at Carroll to after. And what we see is that our students make greater progress in sight word growth with TCI versus not. In fourth grade, we're seeing four more words correct per minute here, four more sight words, right? We're seeing, sorry, that's percentiles, 4 percentile points, 5 percentile, one additional point in fifth grade. In sixth grade, they're growing 2 percentile points, four of them in seventh, and two in eighth. Again, closing the gap with those weaker readers.
So the thing that
So,
jumps out to me here, Jen, is
yeah.
before TCI, especially in those early grades at the lower school, we're pretty good at moving this. We have the
Mhm.
practice, we have kids in there working with their words, with their tutors. But after we added TCI, the horsepower that we're giving those kids is giving them more access to the amazing teaching that's being done in those tutorial blocks.
Yeah, yeah, absolutely. And this data is data that I think really caught the attention of Dr. Gabrielli at MIT and Dr. Marks at Purdue. And we have been able to look at this and look at the growth over time that students are now seeing with oral reading fluency. That when TCI is combined with Orton Gillingham, our students are making faster progress. They're maintaining that progress. They're crossing percentile bands. They're becoming more efficient. Um, let's dig into this more. Let's spend a little more time studying this and doing some research about this. Doing research in schools is really hard, and having enough data to be able to prove something like this it takes a long time to do. We can now do it. And this is actually, for those of you who might have noticed the poster behind Ben on his camera, this is actually a sneak peek at our latest research study, authored by Dr. Rebecca Marks and Dr. John Gabrielli, that shows that students who participated in TCI in grades 4 through 7 showed significantly greater gains on single word reading fluency, on that sight word efficiency measure. Participating in TCI was a strong predictor of improvement in reading scores. Improvements in single word reading exceeded expected progress on age based norms. This is amazing. And this is now, for the first time, data that we're able to put statistical significance behind, data that we're able to publish about, data that we're finally able to really share beyond just what we're doing here at Carroll to show that changes like this, integrating cognitive training alongside a structured Orton Gillingham curriculum, can have a significant impact in outcomes.
So Jen, one of the questions that we've been getting in the Q&A, I want to just kind of talk about right now real quickly is
Yeah.
if these gains in this improved capacity for learning persists after Carroll. And the long and short of it is, and this is the worst answer to give, we don't know entirely yet. However, what we have seen in the past when we've brought in some recent graduates back up to 6 months later, we've seen that the gains that we saw in those cognitive domains either persisted or even improved a little bit further after they came back 6 months later.
Yeah.
Theoretically, what's happening is you're practicing these skills every day. Your reaction time is super important on a sports field. Your processing speed is super important while you're driving a car. Your working memory is super important while you're studying for a test or engaging in your daily life or listening to a lecture in a class. So you're practicing these skills every day, and having that increased capacity is so important for being able to access the learning that's going on.
Yeah. Thanks. Thank you for adding that, Ben. So I want to kind of sum this up here. And I'm sorry, I'm just got a couple of things on my screen that I need to move. So, this is really exciting. This is really important work that we're doing at Carroll. I want to tell you a little bit about what is happening now and in the future, and then we can shift over to some additional questions. So we actually do TCI here with over 400 students during the school year. And we have another 100 plus in the summer that do TCI. We also partner with a school in New York where we have another 150 students doing TCI there as well. So we're continuing to bring TCI to over 600 students a year, and we are going to continue doing that. We are continuing to partner with members of the research community to publish our findings, to share this information. The study that we just had up, we actually had at the International Dyslexia Association conference this past fall. We believe that what we're doing here at Carroll can change reading instruction for kids beyond Carroll. And so we really want to try to make that happen. We are building a consortium of schools to try to bring this work out more broadly. We're also bringing this work into our younger students. So over the last, I'm going to say 4 or 5 years, we have had some really generous grants that have allowed us to develop a set of activities that our younger students do as part of their cognitive um, blocks that they're doing. And the early promising results here is that we are accelerating mastery of sight words. And by accelerating mastery of sight words, we're able to move into that oral reading fluency and into comprehension faster. It's very preliminary data, but it's data that we're really, really excited about. We are so glad to be at a place like Carroll where we continue to do this kind of work. We are incredibly grateful to all of you for your support in doing this work, and we are excited to continue it. Um, I'm going to pause because I have a feeling we've got a lot more questions out there that I haven't seen yet.
We definitely have a few questions.
All right. I moved it on my screen. So we've got on here right now, if you want more information about TCI, you can always email parent questions at carrollschool.org. You can also reach Ben and I at tci@carrollschool.org. Some of the questions that we've got, it looks like, Ben, we have some questions about accessing data.
Yeah, absolutely. So we're absolutely happy to help you guys access the information. Your students' advisors also have access to all of this information, and they have access to our software platform, so they can go in and download you a PDF version of some of these on request.
Um, and I think if you want to have a meeting to review data, the best person to contact is going to be your advisor. And your advisor can coordinate with us, and you will very likely get a one-on-one conversation with Ben Shepherd to go over all of that information with you. Ben, I hate to put you on the spot, but I wonder if you want to talk a little bit about TCI and math, because
Yeah.
while we have been focusing on reading, we know that TCI has some very strong connections to math. Do you want to talk about that for just a minute?
Yeah, I can talk a little bit about that. I want to caveat it with we don't have as much data on math as nuanced data as we do in reading. education as a whole doesn't actually have as much understanding around the nuances of math instruction and the developmental approaches like we do with reading. That said, we have found some correlations between some of our cognitive measures, our measures of visual working memory, and our processing speed measures, which is a symbol digit coding test, which is very similar to what's done on one of the subtests for the WISC. Those are two highly correlated areas to math. Um, and so we look at those in terms of capacity. There are also, these are general skills that we're using across our day for learning. So your shifting attention skills are great for following along a lecture and taking notes. And that's not limited to reading or ELA or history. That goes into science, that goes into math as well. So these skills are absolutely important for math. We don't have as much visibility into the relationships and the specific kind of levers that we could be pulling with improving some of these skills.
Yeah. Thanks, Ben. One of the other questions that we get a lot, and I'm just going to throw this up here, we get a lot of questions about doing TCI outside of school. What are things that we could be doing at home? Are there great video games that kids can be playing? Do we want kids to be playing video games? What are some of the things that I might do over the summer? If you email us at that tci@carrollschool.org, we can actually send you a list of different games that map to some of the different cognitive domains that we're working on here. I think we would want to assure all of you that doing extra TCI during the school year, we're getting them. So they're going to be a little tired. So maybe not playing set every night, or spot it every night on top of doing TCI. But there are a lot of great games that you can play and can be a great way to engage the whole family. And I think a lot of times, Ben, maybe you can speak to this briefly. Parents sometimes worry about video games. The games that we're using are very developmentally appropriate and are designed to be used for cognitive training. We know that your kids are playing a lot of games, and is that good for them or bad for them, Ben?
God, that's a loaded question. Yes. There's a lot of things to go into when you're thinking about commercially available video games. They definitely don't have the same impact as cognitive training that are really focused on discrete skills. But that said, there is research around a lot of broader, more kind of adventure-based games that do have a lot of cool impacts on your cognitive abilities. One, for instance, that I read about years ago was Super Mario 64 has a positive impact on your ability, on your spatial awareness and your ability to kind of understand where you are in space. And if you've ever played that game, you don't really get a map. You kind of have to learn the maps and you have to find your way around this world. And so if you kind of find these discrete niche aspects of games, there's absolutely benefits to them. However, nowadays there's so many ways to be successful in commercially available games that you tend to find a way around the thing that you need to work on the most.
Yep. So leave it to us to pick the games that are going to be harder for them, and you all can stick to the fun games for your kids. Um, I know that we are running up on time. Do we have any other? I'm just looking to see if there's one last question we want to grab, or are we about out of time? I think we're about out of time. So again, if you have questions, please feel free to reach out to us. Um, Again, that email address is tci@carrollschool.org, or parentquestions@carrollschool.org, or reach out to your advisor. If we didn't get to your question, we will follow up with you. Thanks so much for joining us tonight. We really appreciate our time with you.
Absolutely.